I'm still talking here about the Hough transform using the polar representation of the line. Now, let's use this representation to see how to represent a horizontal line. Let's say that this is my image, this is X and this is Y, and here is a horizontal line. Now, I have, of course, to represent the normal to that line. This is the normal to that line, and this is my distance rho. And of course, since rho is below the origin, so this is the origin, and my rho or my normal is below the origin, so therefore rho is definitely positive. Okay, now the theta is 90 degrees. This is 90 degrees. But this was not an issue with the form of slope-intercept of the line, okay, because this can also be represented by the slope-intercept of the line by simply y equal p. And this can be got, of course, by saying that a equals 0. Okay, so y equal ax plus b, setting this to 0 would get y equal b, and by changing b we change how high or how low a line is. This was not an issue with this representation. The issue was with the vertical lines. Now, how to represent that in the using the polar representation of the line? So it is simple, but there is something to take into account. This is actually a special case. This is a horizontal line, and the normal to that, this is a vertical line, and the normal to that line is given by this. So this is my rho, okay? Now, this normal is neither above the center nor below the center. So I cannot say if it is positive or negative. So what to do in that case? And if I cannot say if it is positive or negative, I'm not going to be able to know if I'm going to start my theta from here or from here. Remember, I said that when theta is positive, when the normal is below this origin, the normal like this one, for example, is below the origin, and in this case I can say that theta is positive and start evaluating theta in this direction from the positive side of the x-axis. And for theta that is smaller than 0, this is associated with normals that are above the origin, and in this case we evaluate theta from the negative side of the x-axis. So now we have just to pick up a choice. So we have two choices. The first is to say, I'm gonna start to calculate theta from here, from the positive side of x, right? So if I start from here, evaluating theta from here, theta is gonna be 0, and this value of rho is gonna be negative. Whereas if I start evaluating theta from the negative side of the x-axis, so in this case I would have theta equal 180, okay? So in this case, theta is equal to 180 degrees, and this rho is gonna be negative. And I'm sorry, this is false, this is positive. And in this way, we represent the vertical lines using the polar representation of a line. Now, how to get curves in the theta in row space. So in the when I talked about the AB space and the slope-intercept representation of the line, we got in the AB space for each edge point a line. And I said, for example, that this could be line line I, Li, and I is associated with a given edge point, Pi, for example. Okay, so in this new space we do not get that. So in order to get a curve in the theta row space, I have first to go back to my equation, which is this one. Rho is equal to x cosine of theta plus y sine of theta. And then I have to pick up an edge point. So let's say that my edge point is this one. It has point 0, it has x0 and y0. And what we do, as I said in the Hough transform, is voting. So in order to do voting, you have to evaluate all possible lines that pass from this point. And in order to get the parameters of these lines, all of these lines, and the parameters, by the parameters I mean rho and theta, you have just to take the coordinate of this edge point and replace it here and here. So in this way, I would get rho equal to x0 cosine of theta plus y0 sine of theta. Okay, so this is now just a constant. It is a known value, and this is also a known value. So what I have to do then is just to plot this function, right? So a function, I'm gonna have two axes, the axis of rho, and it's gonna be expressed in terms of theta. So this is my new space. Instead of AB space, we get that space called rho theta. So as I said, theta is between 0 to 180 degrees, and rho is between square root of 2 multiplied by d when it is positive. So this is the maximum value, right? And here we just get the negative value of that, such that d is the distance between the corners of the image. So this is the image and this is d. Okay, and it turns out that this equation leads, instead of a line, to something that is sinusoidal, something like that. Okay, so this is what we get, and this represents all the possible the parameters rho and theta. So this curve here, this curve represents all the parameters rho and theta of lines of possible lines that cross the point or the edge point x0, y0. That's what does this curve represent, and it's the same idea as this line. So this line also represents the same thing. It represents all the possible slopes and intercepts of the lines that pass from the edge point pi. Okay, and to evaluate voting, actually, we use the same principle of intersections. So when we do that for all, so this is associated with one edge point, right? And when we do that for all edge points, what we get is finally an intersection. Okay, so we get something like that. So we get sinusoidal functions, and then we get intersections. So I can say, for example, that this intersection, this row here, and this theta is the represent the parameters of the line that crosses these 3 points. So this is actually the same principle. Okay, and of course, to implement that, we have to discretize this space. So it's the same idea for the AB space. We choose k increments. Okay, we choose k increments for the row, k increments, and then for each increment we evaluate the theta, right? So we get also k increments for theta. So we get basically a grade like this one. And in each cell we would get the number of votes, and finally we take the cell that has the highest number of votes, for example this one, and say that the associated theta and row is finally the detected line. Now there is just a final thing to mention, which is another variant for the representation of for the range actually of theta. So what I said is that I can take my theta in this way. So I start from here. Okay, if the normal is below the origin, so in this case rho is positive and theta is between 0 and 180 degrees. Or if my normal, this is the normal, so if my normal is above the origin, then rho is negative and theta is also in the same range, but I start evaluating theta from the negative side of this axis. This is the positive side and this is the negative side. So I start to evaluate theta from here. Okay, so there is actually another variant. So we can say, for example, evaluate theta from here. This is the y-axis. So I can say this is the positive direction, okay, positive direction of theta. In order to get positive values of theta, we have to move in this direction. And then say, well, instead of starting evaluating theta from the x-axis, I can evaluate theta from the y-axis, okay? So if I move in this direction, I'm gonna get a positive value, okay? And if I move in this direction, I'm gonna get a negative value. So this range is gonna be plus 90 degrees, and this range here, this direction, is gonna be minus 90 degrees, okay? So the possibilities of theta in this case are minus 90 degrees to plus 90 degrees. And in this case, again, in this case, if I get any normal below the origin, the rho is going to be positive. Otherwise, if the normal is above the origin, for example, like this one, so in that case, I start again to calculate my theta from the negative side of this axis. So this is the y-axis, that is the origin from which I start to evaluate my theta. But instead of starting from this positive side, I'm going to start to evaluate the theta from this negative side, from here. Okay, so in this case I can say that this is my theta. And since it goes in the positive direction, this is the positive direction, okay, this is the positive direction, here is it, positive direction. So the possibilities in this quadrant here, theta, are gonna be positive. So the maximum value here is equal to 90 degrees, and here for this quadrant I'm gonna get theta negative, but theta here, maximum value here, is equal to minus 90 degrees. So there are some people who use this representation, but there are other implementations that use this representation, such as, for example, an implementation in the Python OpenCV. They use this representation and the function of calculating the Hough transform.